As we dive into Chapter 6 here, we're going to take a look at Sections 6.1 and 2 combined. Both sections deals with solving inequalities. 6.1 is solving using addition and subtraction. 6.2 is multiplication and division. So these are one-step inequalities. Okay, pretty as basic as we can get. First of all, just a quick review of what inequalities are. Okay, so example 1 here says your school wants to collect at least 5,000 cans of food for a food drive. Write and graph an inequality to describe the amount of cans that your school hopes to collect. So essentially, really, when you're looking at this, you want at least 5,000. That means anything less than that would be a disappointment. So if this is 0, 5,000 is way over here. Okay, and now when it says at least, that means 5,000 is okay, and then anything more than that. So if you can be the number, okay, then you do a closed circle. So we can equal 5,000. So we put a closed circle at 5,000, and then greater than 5,000 means to the right. Greater than is to the right, less than is to the left. Okay, number 2 says you must be under 12 years of age to order off the kiddie menu at a local restaurant. Write and graph an inequality to describe the ages of people who may order off the kiddie menu. Okay, so well, let me go back. I actually didn't write. It says write and graph. So the cans, cans has to be greater than or equal to 5,000, and that's what we've graphed here. Okay. So number 2 says you must be under 2 years of age or under 12 years of age to order off the kiddie menu. So I know that your age has to be strictly less than 12. You can't be 12. You got to be under 12. Okay, it doesn't say 12 and under. It says under 12. So less than 12. But remember, your age can't go below 0 either. Okay, so that's where that second guy comes in. Okay, and so what you have here is you have 0 here on the number line, and you can go over, and again, you could go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, or you could just really put 12 over here somewhere and it'd be fine. I cannot equal 12, so that means there's an open circle at 12. I can equal 0. Well, really, you can't equal 0 because if you're 0, you're not born yet. So open circle at 0 as well, and then what you do is you shade in everything in between your two circles. Okay, that's a compound inequality. We're going to talk more about that as we get going here in the next couple sections. Okay, number 3 says write an inequality represented by the graphs. Okay, so first thing you want to notice is you noticed an open circle here at 0. So I know 0 is my kind of my starting point. Okay, and since everything to the left is shaded, I know that my number has to be less than 0. It can't be equal to because of the open circle. So you would just say x less than 0. And that would be the inequality represented by that graph. In part B, notice at 7, negative 7, so that's kind of my starting point. There's a closed circle. So that means we can equal negative 7, and now you notice we go to the right. So that means that my number is greater than or equal to, whoops, put that the wrong way. My number is greater than or equal to negative 7. So in other words, negative 7 is less than my number, less than or equal to my number. Or you can write it as my number is greater than or equal to negative 7. Those are the same thing. As a matter of fact, I'll usually write it like this. Okay, because I always like my variable on the left-hand side. Okay, when you're multiplying or dividing by negative numbers, when you're solving inequalities, you must flip the inequality. In other words, if the original, right, so if I do this, negative 2x greater than 6, when I divide both sides by negative 2, what this turns into is those cancel, so you have x. This guy needs to flip. So instead of being a greater than sign, it becomes a less than sign, and then 6 divided by negative 2 is negative 3. So that's what we mean when we say flip the inequality sign. Just turn it the other way. Okay, it says, which of the following will you flip the inequality when solving? So part A, flip, right? Because you're going to divide by negative 7. Part B, you're going to divide by positive 3, no flip. Part C, right, you're going to end up dividing by the 2, so no flip. Part D, you're going to multiply both sides by negative 4, so you're going to flip here. And part E, you'd end up multiplying by 4 on both sides, so you would have no flip there. Okay, so those are just kind of getting your feet wet in terms of whether or not you would have to flip the equation or not, or flip the inequality, I should say. Okay, number 5, we're going to do a couple of these together. I'm going to leave a couple for you to do it on your own as well. So we'll do part A together first. So you solve inequalities the same way you would solve an equation. So in part A, if you just thought of this thing as an equal sign, and I said solve for y, what you would hopefully know to do is you would subtract 8 from both sides, and you get y less than or equal to -5. I didn't multiply or divide both sides by a negative number, so my inequality stays the same. Okay, and so now I got to graph this guy. All right, well, it doesn't matter. Call this thing -5 here. Okay, my number's less than, actually, we know we're going to be less than, so we know we're going to have to shade to the left of it. So we might as well put it somewhere we're going to actually see what's going on. So this guy here is -5. We're less than or equal to that number. So I can equal that number. That tells me close circle. Less than means go to the left. In part B, you got to get m by itself. You divide both sides by -4. And what happens here, those cancel, so you have m. I divided both sides by a negative, so this guy has to flip. And 12 divided by -4 is -3. So your number is less than -3. Call this guy right here -3. Our number is strictly less than, so it cannot equal it. So there's an open circle. And less than is to the left. So again, nothing hopefully too drastic here. Okay. Part C, I got to get rid of dividing by 7, so I'm going to multiply both sides by 7. That's a positive number, so my inequality is going to stay the same. -4 times 7 is -28, so x is greater than or equal to -28. Call that guy -28. Okay. It can equal -28, right, because of this guy. And then it's everything greater than. That means go to the right. Okay, so there's your inequality. I'm going to let you guys do D, E, and F on your own. Okay, they're just one-step inequalities. Remember, if you multiply or divide both sides by a negative number, flip the inequality. So in part D, you're going to be flipping the inequality. Okay. And as always, guys, if you get stuck on one of these or you're not sure if you did it right, bring that up in class and we'll handle that. And we'll take care of it and answer any questions you might have. Okay, number 6, some story problems here. It says you are shopping for bicycles. The type you want costs at least $185. You've saved $97. Find the possible amounts of money you need to save to buy the bicycle you want. Okay, so here's the deal. I see at least $185, so that tells me something. And I already have $97. Okay, so I know that I have to save so many more dollars to buy the bike. Well, the amount I have to save is X. I've already saved $97, and I got to save at least $185. So the amount I have has to be at least $185, so it can be greater than or equal to. Okay, so there's my inequality to model the situation where X is the amount of money I need to save. And then it says solve the inequality, simply subtract 97. Okay, and so X greater than or equal to 185 minus 97 is going to be, I believe, 88 if my mental math is correct. And so what that means is that as soon as you've saved $88 more, you can buy a bike. Now, if you want a more expensive bike, you're going to have to save more than 88, but 88 is the minimum amount of money that you need in order to buy the bike that you want. Okay, number 7 says you are checking a bag at the airport. Bags can weigh no more than 50 pounds. Your bag weighs 15.8. Find the possible weights in pounds that you can add to the bag. Okay, so we'll call it weight. So the amount of weight I can add, I'm adding it to the 15.8 pounds that's already in my bag. And I know that I have to stay under or equal to 50. I could be 50, but I can't be any more than 50. So there's the inequality. Subtract your 15.8 from both sides. And you'll find that the amount of weight you can add cannot be any more than 50 minus 15.8. It's going to be 34.2 pounds. Okay, so you can put things in your bag as long as you stay under 34.2 or equal to it. You can put exactly 34.2 pounds in your bag if you have that much more stuff. Number 8 says you have a budget of $45 to buy pizza for a party. Pizza costs $7.50 each. Find the possible number of pizzas you can buy. Okay, you're on a budget of $45. That means you cannot go over $45. You don't have any more than $45 to spend. Okay, so it's $7.50 per pizza, so times P, each one $7.50, and I know that that number has to be less than or equal to 45. Okay, I can't go over the 45. So now there's your inequality. Solve it. You're dividing both sides by 750, and you find that the number of pizzas you can buy is less than or equal to, I'm going to grab my calculator here because I don't know this off the top of my head, 45 divided by 7.5 equals 6. I guess I could have figured that out. Okay, so in other words, you can order up to 6 pizzas. Can't order anything more than 6 though. And then the last one here, number 9, says, in example 8, suppose you had a budget of 50 and pizzas cost $8. Find the number of pizzas you can buy. So it's the same problem. 8 pizzas and you're on a budget of $50. Divide both sides by 8. P is less than or equal to, that's going to be 6.25. Okay? And again, it goes back to, obviously, you can't order 0.25 of a pizza. Okay? So the highest number of pizzas you can actually order is just going to be 6. Okay? And then anything less than that. So hopefully this idea of inequalities, setting them up, solving them, is something that you're going to hopefully be fairly comfortable with. Again, it's very, very similar to things that we've already done, namely solving equations. And again, we'll look at this more in class and spend as much time as we need to make sure that everyone's on the same page and feels comfortable.